called stratified random sampling. So simple random sample was basically just take a list of individuals, label them, start picking at random. So it gave every single person within the sampling frame an equal chance at being selected for the sample. Okay. Now, let's start off with an example here. So here's a scenario. We want to learn how students feel about funding for the football team at a large university. The campus is made up of about 60% men, 40% women, and you suspect that men and women have different views on the funding. So you decide to collect an SRS of 100 people and ask them how they feel. Should we have any concerns about our sampling choice? So if we want to go out, we want to ask the student body how they feel about funding for the football program. We suspect men and women are different in their views on the funding. We're going to choose an SRS of 100 people from this large university. Is there anything there, sampling-wise, that would give us pause? Grace, what do you think?
Since there's like way more guys than there are girls, and they're trying to like see the difference in opinions, having like just random 100 people would like make the sample unproportional between the men and women.
Okay, so if we did an SRS of 100 people, right, we might get a sample that has way more women than men, right? Now, if we look at our population, we said on the entire campus, we have about 60% men, 40% women. So if our sample had way more women than men, would our sample necessarily be representative of the overall population? Not necessarily. We might be misrepresenting different groups within our population, right? We also, with selecting 100 people, we might also run the risk of getting a sample made up entirely of men or entirely of women, right? There is that possibility that when I select randomly 100 people from this large university, I might get 100 men for my sample, or I might get 100 women for my sample. And if I feel that there truly is a difference between the views of men and women, then my sample is not going to give me accurate information, right? So this would be a scenario. We said SRSs are good in most cases, but there are times where other sampling methods might need to be utilized to counteract anything that might show up within the problem itself. So here, an SRS might not be the best option. So let's talk about a second type of sampling that we could possibly use here, and that's called stratified random sampling. With stratified random sampling, it's going to be very, very similar to SRS. So it's going to be very similar to a simple random sample. The only difference is that we are first going to take our population and we are going to break them up into what we call strata. Now, for our purposes, when we say strata, we're talking about groups of similar individuals. So, for instance, if I wanted to answer, or have the student body here at PLHS answer a certain question, how do you feel about this topic? Okay? And I wanted to go out and just take a simple random sample of the entire student body. But I feel that possibly, depending on what class you happen to be in, whether you're freshmen, sophomore, juniors, or seniors, you might have differing opinions on the particular topic. So if I was to think of that beforehand, what I would want to do, without just going out and taking a simple random sample, because if I do that, I could get a sample without any freshmen, I could get a sample without any seniors, so I could have a sample that doesn't represent our entire population. So the first thing I would do is I would split the student population into freshmen, sophomore, juniors, seniors. So I'd go to my freshman group, and I would randomly select a certain number of students from that group. And then I'd go to my sophomore group, and I would randomly select a certain number from that group. And then the same thing for juniors, same thing for seniors. Now, when I bring them all together, I know that my sample has a certain number of people from each of the different groups that I want represented in my overall sample. So when you're looking at your population, and you're looking at the question or the information you're trying to gather from them, if you feel that there are groups within the population that might be different in opinion or in response, you would want to break your population up beforehand. Break them into strata, and then within each strata, you would want to select randomly a certain number of people for each piece of your sample. So the big thing here, when you stratify, is that you're going to take your population before you start sampling, and you're going to break it into groups that are similar. So group A is going to be similar within itself. Everybody in group A should be pretty much the same. Group B should pretty much be all the same within that group, and so on. Once we've broken our population up, then we perform an SRS on each of the groups we created. So you're still performing an SRS, which means you would take group 1, label everyone in group 1, and perform an SRS on that group. Then you'd go to group 2, label everybody in group 2, perform an SRS, and so on for as many groups as you created for your particular scenario. So let's break them up first, then perform an SRS on each group. So another example, if you're trying to figure out voter intentions or voter opinions, you might want to divide your population first into urban, suburban, and rural. So people who live in the city, people who live on the outskirts of the city, people who live in the country. Because depending on where they live might affect their opinion or their answer to a certain topic. So you break them up into the 3 categories first, and then select from each of those categories. That way your sample more closely represents that population of interest. Does that make sense? Okay. So when we choose our strata, you're going to choose your strata based on facts known before the study. So based on things that you think or know ahead of time. So if I had a certain question like we talked about for the student population here, but I felt ahead of time that freshmen, sophomores, juniors, seniors would all have differing opinions based on grade level, then I would want to make sure I separate my population into grade level first and then sample from each group. So if you think that people within your population, groups within your population might differ in opinion or differ in response, you'd want to separate first based on that information. And then you need to make sure that the individuals within each group that you create are similar. So another type or another common grouping would be by age. You wouldn't want to necessarily have young people mixed in with old people within one strata or one stratum. Because depending on the question, they might have differing opinions based on age. So you'd want a group of young individuals, a group of maybe middle-aged individuals, and then a group of older individuals. So that way you can classify by age first and then get a sample from each of the groups from there. So let's revisit our football funding problem here. So we said an SRS probably would not be the best solution here because we run the risk of getting a sample that would not be representative of our population. So if we take this same idea and now, using this idea that there is a stratified random sampling technique we can use, how would we improve this sampling? Okay, so break them up into men and women, select a certain number of men, select a certain number of women, right? So I like the first part of that. I don't necessarily like the 50-50. Okay, if we want to most closely represent our overall population, right? Since we know that the proportion of men and women are 60-40, then in our sample, we want to try to replicate that as much as possible. So we would break our population up into men and women, and then we would do an SRS of 60 men, and then do an SRS of 40 women. So we'd go through the list of all of the male students, and we'd select 60 of them randomly. And then we'd go through the list of female students, and we'd select 40 of them randomly. So now, not only do I guarantee I have both men and women in my sample, but I have them in the same proportion that my overall population does. So this sample would get me to most closely represent my overall population. Does that make sense? Okay. Now, if we didn't know the breakdown of men versus women on the campus ahead of time, which would be something we might want to look into, your best bet is do the 50-50 then. At least you get both men and women within the sample, which is still going to get you pretty close to what you want. Okay, but since we know the breakdown, we can get it as close as possible by doing the 60-40. Everyone okay with that? Okay. All right, so then just a couple ideas with stratifying. The most important benefit for stratifying is reducing variability. If we think back to that college problem, if I had just taken an SRS, I might have lucked out and received a sample that was 60 men and 40 women, which would be nice, but I can't guarantee that with just an SRS. I might have gotten a sample with 90 men and 10 women. And then the next time I go out and sample, I might get 40 women and 60 men. Or I might get 70 women and 30 men. Each time I go out and do an SRS, I'm going to get a drastically different, more often than not, a drastically different group of people. Which means my answers are going to be all over the place, more than likely. But if I use stratifying, then I'm guaranteed to have a more closely representative group when I go out and take an SRS over and over again. So if I were to do that process with stratifying built in, I'm still going to always get 60 men and 40 women. I'm going to get a different 60 men every time, or more likely than not, I'm going to get a different 60 men and a different 40 women, but I'm still going to have the 60-40 makeup, which is going to get my answers closer together overall. So when we stratify, we can take some of that variability we see from random sampling and we can reduce it. We can make it smaller overall. Okay, so if we have to go out and take additional samples, they're going to be more like one another than if we simply did an SRS every single time out. With that then, and we haven't talked about bias yet, we'll talk about that tomorrow, but stratifying, in most cases, can help reduce bias. It can help reduce the push one way or another in our results. The other thing stratifying allows us to do is, since we have broken them down into groups ahead of time, we can look at and analyze any important differences between the two groups. So when we go out and select our 60 men and our 40 women in our college example, we can actually go back and look, well, how did the men typically tend to respond, and how did the women typically tend to respond? Were they actually fairly similar, or were they different like we suspected from the beginning? So you can notice any major differences between the two groups and how they differ. So an SRS doesn't necessarily seem to be the best option. This could be something you could use. So stratifying, generally it's going to be something where ahead of time you think, okay, I think these different groups within my population are going to be different, so I want to make sure I collect a certain number from each of those different groups. So you split it first, then take your SRS. All right, and that's it. So